on this culminating task, transforming shapes. First it says to draw a rectangle, parallelogram, square, or isosceles trapezoid in the coordinate plane so that portions of the shape are in each of the 4 quadrants. Explain what would happen to your shape if you transformed it using each of the given rules. So I've chosen to do an isosceles trapezoid, and I put little stars on the vertices. And then it doesn't tell you to do this, but this helps me out to list all the coordinates. So I started here with, in the first quadrant, that point is 5, 10. And then going counterclockwise, -5, positive 10. In the third quadrant, it's -15, -10. And then finally, 15, -10. Okay. And then the task says to perform these transformations. So the first one it says to do is -x, y, and explain what happens. So let's see. In order to do that, I need to actually find out what the new coordinates would be. So I could basically, let's see, -x, or opposite of x. So the first point will become -5, 10. The next one will become +5, 10. +15, -10. Notice y stays the same. And then -15, -10. And then draw that figure. Let me get some little stars, maybe, to see what that would look like. Okay, so we have a point at -5, 10. So -5, +10. And then 5, 10. And then 15, -10, 5, 10, 15, -10. And, whoa, -15, -10. Okay, so if I connect those, you see we get the same shape. So what happened to it? It might be easier if you're doing this on paper to see that it actually rotated. Okay, so let's look at the next one. I just skipped around. I think this is number 4. It says to do x and then y -2. So the x's all stay the same, but y, we have to subtract 2 for each one. So it'll be 8, 8, -12, -12. Because -10 minus 2 more would be -12. So let's see what that looks like. So 5, 8, -5, 8, -15, -12, and 15, -12. So what happened to the shape now? Comparing it back to the first one, it looks like what did it do? The y's went down 2, so it shifted it down 2, right? The whole shape shifted down. So do that for each of the ones in your task. I would recommend making a T-chart for each one and graphing it. You can graph them all right here on the same graph if you want, or it might get a little cluttered. So you can see what happens. Then answer these questions. This is which of the transformed figures are congruent to the original figure? So that first one I did, oops, let's go back to the presentation. The first transformation we did, these 2 shapes were congruent, right? So you could say that when you reflected over the y-axis, it stayed the same. It could move around and still be congruent, right? Even when we shifted it, it stayed the same shape and the same size. That's all. Another word for that is to call it a direct isometry, when it stays the same orientation and the same size. Okay, so there. See how notice that the shape didn't really change. What else do we have to ask? Let's keep going. Number 12, it says, create a rule or set of rules to make a 90-degree rotation of your figure. Explain how you decided the rules for both. So in the first set of parentheses is where you'd put your original ordered pairs. So in my case, it was like 5, 5, 10, negative 5, 10, negative 15, this one. And then it says, come up with a rule for a 90-degree rotation. Let's get a new screen here. Oh, that's not what I wanted. So this is the start. What would we need to do to rotate it 90 degrees? Okay, and just I think after you do all of these up here, you'll see which one rotates at 90. I don't want to give away the suspense, but then write the new ordered pairs on the right-hand side. Okay? Go through the rest of these questions. If you have any questions, just let me know. I'm here to help. Good night.